Okay, so I want to talk about how we find C. As I mentioned, when you find your antiderivative, you'll get something, something, something plus C. But C could be absolutely anything for the reason that I gave you in the previous video. So the question is, how can you find C? And I would require that you would give a single point that function was going through, because only one of your infinite number of possibilities for your function can go through that point. So I'm going to do this problem that's right in your notes. Please see the notes. This problem is done in its entirety. I'm going to walk you through it now. All right, so this is how you started off. Okay, so they tell you that your derivative equation, right, your derivative of f of x is 3x squared plus 4x minus 1. And then they tell you on f of x, you have the point 2, 9. So they're giving you the one point that your function goes through. All right? And in the instructions, it'll say recover f of x for this initial condition. What's the initial condition? Right there, right? They're telling you the point, the one point that your function is going through. All right, so fine. So if you start off with f prime, the only way that you can get to f, let's think about that. If we're at f of x and we go to f prime, then in order to get there, we took a derivative. Right? But if we start at f prime and we want to go back to f, which is what they ask you to do, it says right there, recover f of x, then you're going to take the antiderivative. All right? So we want to get to f of x. The only way to get there is to find the antiderivative of f prime of x dx. All right, hold on a second, let me move that up. Okay, again, the antiderivative and the derivative, they counterbalance each other, right? They cancel each other out and leave you just with f of x. All right, so here we go. This is the antiderivative. Now we're being very specific. They tell us what our derivative is. It is 3x squared plus 4x minus 1 dx. Okay, I'll explain where dx comes in the near future and what this integral notation means as well. Okay, so then f of x equals, notice all I've done is just, I've done that. Now I'm going to get into this. Okay, 3x cubed over 3 plus 4x squared over 2 minus, there's an x to the 0th right here, so x to the first over 1 plus c. Right, so this is our general f of x function. We know that c could be anything. C is anything at this point, right? So it means that we have a class of functions that are shifting up and down the y-axis, right? But fortunately for us, we have the one point that the function goes through. So if there's a bunch of parallel functions, only one of them can go through this point 2, 9. All right. So let me simplify this before I move forward. So then f of x equals x cubed plus 2x squared minus x plus c. All right. So I'm going to use this information that we have up here. Look closely. It says f of 2 equals 9. So this says when x equals 2, you've got a y value of 9. So let's go here, because it means if x is 2, 2 cubed plus 2 times 2 squared minus 2 plus c, you should get a y value of 9. F of 2 equals 9. When you plug 2 in for all of the x's, you should get a corresponding y value of 9. So let's see, 8 plus 8 minus 2 plus c equals 9. Let's see, 16, 14 plus c equals 9. Subtract 14, subtract 14, tells you C equals -5. It's magic. All right, so I'm going to take this C value, and let me show you where I'm going to put it. I'm going to put it right, oops, this is probably more appropriate, right here. And that tells me that the function I'm looking for, f of x, equals x cubed plus 2x squared minus x minus 5. There it is, right there. You have your C. So now you have the function that is appropriate for this initial condition. Okay? I want to try another one that's straight out of your homework. And that is problem number 40. 40 looks good. Okay, so here's your homework assignment. Let me show you which one I'm talking about. There it is. Okay, so please look at the instruction. It says in problem 35 through 40, the slope f prime at each point is given along with a particular point on the curve. Use this information to find your function f of x. Okay? So let's think about that. For problem number 40, 40, what do we have? For 40, give me 1 second, please. We have that f prime of x is equal to 3 over x minus 4. And they also tell you that the point that you're going through is the point 1, 0. Right? So in essence, they're saying f of 1 is equal to 0. Right? This point is on your f of x function. So then let's get to it, because they say find f of x, right? And we don't have that. This is a question you're always going to have to ask yourself. Do you have the function that they're asking for? You don't. You have f prime. So let's see. If we started with f and we went to f prime, going this way, we take the derivative. But we don't. We're starting here at f prime and we're going back to f. Then we're going to take the anti-derivative. Right? So let's get to it. If we want our function f of x, then we're going to have to find the antiderivative of f prime of x dx, which equals the antiderivative of 3 over x minus 4 dx. Just like that. All right, let's keep going. So then our function f of x is equal to, let me rewrite this. I'm going to do them one at a time. 3 times the antiderivative of 1 over x dx minus 4 times the antiderivative of 1 dx. Right? Notice I pulled out the coefficient so that I can more easily take the antiderivative. Okay, what you can do is make this x to the 0th there if it makes it more easier for you to understand. This is what I asked you guys to memorize. Right? So then your function f of x equals 3 times the natural log of the absolute value of x minus 4x to the 1 over 1 plus c. All right, we're almost there. But we have to remember that at this point, c could be anything. So we're going to go all the way back up here where we say if x is 1, then your y value should be 0. Right? So this equals 3 times the natural log of the absolute value of 1 minus 4 times 1 plus c is equal to 0. All right. Throw that in your calculator. You'll find out that's 0 minus 4 plus c equals 0. Then you're going to add 4 to both sides. And you'll get that c is equal to 4. Right? So now we don't have an infinite number of possibilities. We only have one function that works. let me show you this. I'm going to widen it so that you can see the work. I want to take this C value and I'm going to plug it right back in here so that I can have only one function. And that is f of x equals 3 natural log absolute value of x minus 4x plus 4. One function that is appropriate for this initial condition.